Okay. Hello, everyone. Just one person, actually. Today we will cover integrated reasoning, a new, well, actually an old session from the old GMAT exam. But now an important session, important part of the new format because it actually affects the total score. So for this session, we're going to go over the different types of integrated reasoning questions. We will um, discuss the general steps, the general rules of thumb for approaching each type of question so that we will be able to answer the questions in the allotted amount of time, which is usually a little bit low for the amount of information they give us. So we'll find the best way to interpret the data and then figure out the correct answers. So there are three main types of integrated reasoning questions. Number one is graphs and tables. As the name suggests, for graphs and tables, they're going to show us some data and in kind of a visualized manner. So let's try this question. Also, a rule of thumb for practicing on GMAT Club, if you find questions that have very low percentage correct and around, say, below 35% correct, then you can skip that question because it's usually not realistic. Try to find questions that is explicitly that has the source explicitly stated as official guide or GMAT prep. They are kind of the questions that are closer to the real thing. Okay, this one sounds nice. Okay, we can try to spend some time with this question. So as you can see, graphs and tables are questions that have some sort of like visualization of the information. And for such questions, the first thing you want to do is instead of reading the prompt, you want to take a look at the graph or the table they're showing you first and trying to have a general idea of what it is presenting, what kind of data, what kind of information it is presenting. So you can see that this is sort of like a graph for steps and there are conditions along the graph. So let's take, say, 15, 20 seconds to take a look at the graph and then we'll discuss what this graph is saying. And then we'll go to the actual prompt, the explanation down below. And then after that, we'll go into the specific answer choices. I'm going to send you the link in the chat. Okay, so let's spend 15, 20 seconds looking through the graph. Okay, can you quickly kind of describe what the graph is saying in your words?
This process.
Okay, so it's telling us about a process.
And yeah, it's telling us about a chemical processing process. It starts with heating and
Okay.
If it's not adequately degasified, it will undergo additional heating
For 20 minutes.
For 20 minutes.
Okay, that's right.
Then sifting for 5 minutes. But if it's heated already, then only 5 minutes additional.
Okay, so it goes straight to sitting, no more additional heating.
No. And then they mix the HCl in for 20 minutes. And if it's not adequately reacted, then another 20 minutes.
Okay.
But if well mixed, well reacted, then goes through filtration for 10 minutes.
Goes
Then
through
drying.
filtration 10 minutes. And then drying for another 60 minutes. Okay, so yeah, that sounds like the process for that chemical processing situation. So we have some idea, and sounds like our interpretation is close to what they're giving us. So now, with that context in mind, we're going to start reading the prompt below. So let's take another 20 seconds to read the prompt and then discuss what the prompt is saying. Okay. Alrighty. So what's the prompt what's the prompt telling us?
The prompt is giving us information about the share of batches that either require additional heating or requires a second mix of hydrochloric acid.
Okay, so it would appear that the first half of this paragraph is describing the chart as we already figured out above, but the latter half or the last 1/3 is giving us some additional information that's not expressed in the graph. 3/4 of all batches do not require additional heating. So this step, additional heating, this 20-minute step here is not needed for 3/4 or 3/4 of the batches. Half of the batches require second mixing with hydrochloric acid, and none needs third mixing with the hydrochloric acid. Okay, so this step, HCl mixing, is repeated twice for half the batches. Okay. All right. So now we're gonna get to the questions. So you can see that we have two selections here, and they are not of the same sentence. So meaning that we don't have, so we don't have to select one option in accordance with the other. We can solve these two questions separately. Okay. All right. So let's take 4 minutes to answer these two questions. Alrighty then. So what's your selection for the first question? The average time in minutes that a batch of ingredients to make it all the way through the process is shown is
140 minutes.
140 minutes. Okay. The average number of stages that a batch undergoes is what?
5.75.
5.75. So before we go into checking the answer choices, let's go through kind of the calculation and see how we arrived at these numbers. So the average time in minutes that a batch of ingredients to make it all the way through the process shown is 140. So how did you get to 140?
So since it's average for the four, well, I assume that there are 4 batches. Is it? Yeah, I assume that there are 4 batches.
Mm-hmm.
And then I take the average of each step for all the batches.
Uh-huh. So one keynote here is that because they are talking about only the ratio. So we have 3/4 and half. So this is a typical kind of clue for any percent or ratio question, that if they only give you information about ratios, it means that you can really just plug in any values for those variables to make the calculation easier. So in this case, we can just assume that there are 4 batches. And whether there are 8 batches or 16 batches or 20 batches, then the ratio will still be the same. Okay, so let's just say assume there are 4 batches, and then
So the first step will be 30 minutes for 4 batches over 4
okay,
equals 30 minutes.
so 30 minutes for all 4 batches.
Yes, then divided by 4.
Okay, so each is 7.
It is 30 times 4, then divided by 4 equals 30.
Okay, so still 30 minutes per batch, basically.
Yes.
Okay. And
So the second step, some requires additional heating, some doesn't.
so what was the
30,
portion?
1/4.
Okay, so one batch needs
20 minutes.
additional 20 minutes. So in total, that batch needs 40 minutes, right?
No, here they just ask if it requires additional heating.
Oh, sorry, yeah, require additional heating. So that batch is 20 minutes, right?
And the other 3 is 0.
Okay, the other 3 batches are 0.
So 20 over 4 equals 5 minutes.
Okay, so we can average out here to say that at this point, each batch is going to have 5 minutes of additional heating, right? So in put it another way, we can think of this as, so let's say that one batch needs an extra time for additional heating, and these are the other batches. So we're just gonna take this difference here and we're gonna distribute it out equally to all the 4 batches. And so this is that additional extra minutes, and that's the 5 minutes. Okay.
Yes.
And then
for sifting, it's again 5 times 5 minutes times 4 over 4 equals 5.
okay, so each batch is gonna sit for another 5 minutes. So
Yes.
at this point, we can see that what's the total minutes for each batch now?
35 plus 5.
Okay, 30
40.
plus 5 is 40. All right. And then
We go to HCl mixing.
uh-huh.
So for this step, some requires all of them requires only 1 mix, but some
Okay.
requires an additional second mixing. So
Okay.
again, we have 20 minutes there. So 40 plus 20 times equals 60 minutes. Then for two requires 20 minutes. So 2 times 20 equals 40. And 2 don't require 20 minutes. So 2 times 0 equals 0.
Okay, so let's visualize it like we did for this step. So we know that half of the batches need additional, or like the second HCl mixing, right?
Yes.
So 2 batches would have how many minutes of mixing in total?
40.
40 minutes per batch. And then 2 batches would not need this additional mixing, so it would still be 20 minutes per batch. So now we can add all these up and then divide it by 4 to find the average minutes needed for mixing per batch. So it'll be 40 times 2 plus 20 times 2 and then divided by 4 plus 20 times 2 and all divided by 4. And how many? How many? So how many minutes would that be?
30.
30 minutes per batch. Okay. So far we have the 40 minutes all the way up until this point, and then now we have another 30 minutes. So in total, each batch is taking how many minutes?
We have 40 plus 30, 70.
Okay, 70. So far it's 70 minutes. At this point, it's 70 minutes total per batch. All right, and then
the last two steps are 60 minutes and 10 minutes.
Filtration and drying
all required.
Yeah, all applied for all the 4 batches. So that would add another 10 and then another 60 or added another 70. So 70 plus 70 is total is 140 minutes. So that is the answer for this first question, 140. Okay, so what about the second question? Why 5.75?
I repeated the same process with each step. And so
you repeat the process of each step. So let's say, for example, for the additional heating step, what exactly did you do for that additional heating? Let's say we start with heating and then additional heating.
So the first step that requires 30 minutes of heating at 200 K.
So let's say that's one step.
So the average for 4 batches is 1. So I put 1 under one step. And so for additional heating.
Okay, and then additional heating, how many more steps would that be on average?
1/4.
Okay, 1/4 or 0.25 steps?
Yes.
Right, because this is additional heating itself is 1 step, but only 1/4 or one batch needs this additional heating step. So we divide that by 4. So it adds another 0.25 steps, or total is 1.25 steps per batch so far. Right, and then we can do the same thing for the other steps. Right.
Yes.
Like HCl mixing, we add another 0.5 for each batch. So in total, it would be 1 for heating. Heating is one step. Additional heating is another 0.25. Seating is 1 step. HCl mixing is how many steps is that?
Half. So
half?
0.5.
Are you sure it's 0.5?
Okay, plus 1.
Yeah, because all the batches go through the first round of HCl mixing, and then half needs the second round of HCl mixing. So total is 1 plus 0.5 or 1.5. Right, and then filtration is another step.
Equals 1.
And then drying is
1.
One more step. Okay, so 1 point. We add all these up, and that gets us 5.75, right?
Yes.
Correcto. That is correct. Submit. Yes, answer is correct. Okay, great. So yeah, that is one example of graphs and table type of question. And this one, I think actually this one is, even though the accuracy is kind of low, but it's quite close to the real thing on the real test, say. Okay. So yeah, the takeaway for this type of question is to read look at the graph or the table first, have an idea of what it's saying, and then read the prompt later. It will save us some time. We don't have to go back and forth among this information. And a key thing to note here is that integrated reasoning, unlike quantitative questions, they tend to give us a lot of information. Not all of that information can be used or should be used. The point of these questions is to overload it with information and test us whether we are able to figure out which piece of information is important. So keep that in mind. Alrighty, so let's move on to another example. Let's try this one. Oh yeah, this one's all right. Once again, let's take 15-20 seconds to look at the graph and summarize what it's saying.
The graph shows the number of medals for each country in each year.
So number of medals by years in kind of 4-year increments. So basically during the Olympics, 96 Olympic, 2000 Olympic, 2004 and 2008 from how many countries? 7 countries. Right, 7 countries. Okay, great. And now the problem below is basically just summarizing what we just figure out from the graph. Using the drop-down menus, create the most accurate statements based on the information provided. Okay, so similar to the previous question, we have 2 statements. They're independent, so we can just work at one at a time. Let's spend 3 minutes to figure out the answer choices. Zoom recording. Okay, so let's go through the answer choices. Question number 1. The variance in the number of medals won is the least for. So what is the variance? Can you quickly explain what does it mean by variance?
The variance calculate the deviation from the mean.
So yep.
So here we would be looking for the country with the least variation.
Yeah,
which means
the least variation
from the mean.
The most stable country, and that would be
the line which is the straightest, and it goes, to the side, horizontal, closest to horizontal.
And which country would that be? Which line would that be?
And so France at 40.
France at 40. So least variance meaning that it's rather stable. It could go up, it could go down, but it doesn't change a lot like this. No, this is high variance. This is low variance. This is even lower variance. As long the closer it resembles to a straight line horizontal to the ground, the lower the variance is, and the lowest variance is 0. So from the graph, it seems that France has the lowest variation. Okay, second question. If for each country the point representing the medals won in 2004 had been on the line determined by the points representing medals won in 96 and 2000, then the country that would have won the greatest number of medals in 2004 is?
Here it requires a bit of imagination.
Yeah.
So it's asking us if it's going at the same speed and which one will have the greatest number of medal in 2004.
Mhm.
So we would just look for the line which has the steepest
Yeah,
slope
slope
and
from
sloping up.
yeah, and 96 to 2000. So which one would that be?
Russia.
Russia. Okay. So yeah, Russia from 96 to 2000 had like the massive difference, massive increase in the number of medals. And we can confidently say Russia because Russia is not kind of like one of the low countries that's sorry, not one of the countries that started with a very few number of medals. So, for example, what I mean by this is, so we have these two lines. So obviously, that line on top, line number one, is not as steep as line number two, but because line number one starts way higher than line number two, so let's say at the year ending year 2004, I think, yeah. The ending point for line number one is still higher than line number two, even though line number two is way steeper than line number one. So we have to pay attention to the starting point too. But in this case, Russia's starting point is not too low either. It's actually the country with the second highest number of medals. So it's likely that if it continues the trajectory of 96 to 2000, it will have the most number of medals. What happened? Probably communism happened. And so it doesn't have as many medals anymore. Okay, let's see if the answers are correct. Yes, the answers are correct. Congratulations. Alrighty. Okay, so I think that's it for our practice for tables and graph. We haven't found a question with table yet, but in your practice, in your to-do, there would be questions about table type. And just remember that for table questions, you can actually sort the table by clicking on the columns or the rows. Okay, so we're gonna practice a different type of question, which is multi-source reasoning. We're gonna go through some rules of thumb, some tips and tricks, some keynotes. Oh wow, this question seems not very realistic. Oh, okay, it seems to make more sense. Alrighty. Okay, so for multi-source reasoning questions, basically they're gonna give us a bunch of text, not really reading comprehension kind of text. Like it's not that thick. It's not that highly technical or highly academic, but it's still a lot of text to kind of read more efficiently to reduce the amount of time needed to go through the text. The first thing you want to do is go through the different tabs, read the names of the tabs, and have some idea the relationship among the tabs. So here we have KJ reservoir, we have methodology, and then we have fish reproduction. So we can make kind of an informed and intelligent guess here that, okay, so sounds like the text here are talking about some sort of experimental research done in this reservoir about fish reproduction. And then in the second tab, they are talking about the approach, the method that the researchers are conducting to get the results. And so the text, each text is going to provide some additional information to explain. And like reading comprehension or word problem questions, when they are giving you this much information, would be nice to take notes in your scrapbook, in your sketchbook. You don't have to take a very verbose, very long-winded notes. Just abbreviations are fine. Hieroglyphics are fine. Drawing icons, everything is fine. Okay, so let's take 2 minutes to go through these 3 tabs, and then we go back and we summarize. And okay, another thing I want to take note here is that they even have a graph here. So we will apply the approach we just did for tables and graph questions. We look at the graph first, read the columns and the rows, understand what they're trying to say, and then read the text later. All right, so let's take 2 minutes. Okay, so let's do some application here. Okay, so first question. Actually, before going to the question, let's kind of summarize a little bit and articulate the relationship among these 3 tabs. So tab number 1 is talking about some context information, right? What they're telling us in tab 1, tab 2, and then tab 3. Can you briefly explain? Hello?
Yes. You are asking me to explain the tabs?
Yeah, just quickly summarize and then what the relationships are among the 3 tabs.
The first tab talks about the number of fish at the start of the season.
Mm-hmm.
And then they provide some information about the percentage of the population that survives until the next May.
Mm-hmm. Right, so there's some key information that we need to take into account to remember or take note. So May is kind of a date of checking the population, and the fish population should be at least 1,500. And if it's less than that, they're going to find more and to make up the difference. All right, and then mid-September is kind of a breeding season for these fish. And after the breeding season, end of September, 80% will survive until the next May that the researchers are gonna check the population again, and then the lake cannot support more than 2,000 fish, right? Just 2,000 and below. The second tab is, well, the important thing is this formula here. So they're talking about the methodology that they use to estimate the total number of fish in the reservoir. So what's the methodology? Can you briefly explain?
So here they would take the number of fish common to both group and divide it by the number of recapture group. This number will be equal to the number of individual in the capture group divided by the total population.
Yeah. So basically they're capturing the fish twice, 2 groups. The first group is going to get tagged so that in the second group, they're going to figure out which fish of the first group got recaptured. The ratio of recaptured fish in the second group would be equal to the ratio of the first group to the total population. So you're going to need the number of fish in the first group, the number of fish in the second group, and the number of fish that are mutual, that are in both groups, to find the total population, basically. Okay, and then the third tab, what the third tab is saying, what is it about?
It shows a chart about the population increase. So the axis, the y-axis shows the population increase in percentage. The x-axis shows the fish population in individuals.
The x-axis show fish population, the y-axis show a population increase, and you got that curve, that bell curve, that kind of hill-shaped line. So it's basically showing us kind of a relationship that up to a certain point, as fish population increase, the population,
the population size increase,
Yeah.
the rate of growth will decline.
Yeah, past a certain point, and it seems like in this graph, that point is 1,000 fish. So if the population exceeds 1,000 fish, the rate of increase, the rate of growth in the population is going to decrease. Okay. And then before that 1,000 mark, the rate of growth is also going to increase. Alrighty. Okay, so first question. Based on the information provided, which one of the following was the team's estimate of KJR's fish population? So to find a fish population, we're going to use that formula in the second tab. And the information in here. But can you briefly explain how you approach the first question?
So the first question asks, which one of the following was the team's estimate of the fish population?
Yeah.
I got confused here because in the methodology tab, they provide an equation with P, which is the total number of population.
P is the population.
Yes, but the first tab, the KJ reservoir tab also shows an estimate. So I used this estimate. Because they said that on May 1st, they had 1,500 fish. So
wait, hold up. Where does it say that they estimate that there are about 1,500 fish?
They provide that information.
You mean here? So they're saying that the team has determined that the fish population should be no less, not is no less than 1,500 fish. You know what I mean?
Yeah, it could be higher. It could be to 18,000, 1,800, right?
Yeah, it could be 1,800, but then again, that number of 1,500 is basically just a benchmark for them to decide whether they need to capture more fish and then release more fish into the lake, or if there are already enough fish.
Okay.
It's just a benchmark. It's not an actual estimate of the real fish population.
So I might have gotten the right answer.
Okay, so you apply the formula here.
Okay.
So we got the number of fish in both groups divided by the number of fish in the second group. That's n. And number of fish in both group is here. This number here equals to m over p. M is the number of fish in the first group. And then p is the total population. Okay.
Okay.
So what information do we have?
We have 60 fish.
Yeah. We have 60 fish in the capture group. So n equals to 60.
No, n equals to 60.
Sorry, n or m, which one is equal to 60?
Not n, m. The first
M
group
is equal to 60.
Yeah.
Oh, okay. Yeah, this is 60. And how many in both groups?
5.
5 in both groups. And how many in the second group?
100.
100. Okay, so we have 5 over 100 equals to 60 over p.
So I cross multiply. We have 5p equals 60 times 100.
Cross multiply. So 1 over 20 equals 60 over p. And p is equal 1200. It's 1200. Is it? We're going to check for that later. Well, actually, I think we can check now. Oh, nope. Correct. Okay, second question. Assume that KGR's fishing season will continue for the foreseeable future, and that on May 1st next year, the wildlife management team plans on 60 fish in the capture group and 60 fish in the recapture group. Okay. So let's plug in the formula. So number in both divided by
Recapture.
second, right, equals first group, so population. So number in both, well, actually they don't tell us how many in both. They just tell us that there will be 60 in the first group and then 60 in the second group. All right. And so
So in question number 2, it asks whether the team will need to restock the reservoir, which means that whether the number of fish will be lower than 1,500.
yeah.
And in the tabs, they show us the number of fish in both groups. So we just plug in for all 3 options.
All right. So we see that the 3 statements here are similar in that they're talking about the number of fish in both the capture and recapture groups, or basically they're talking about this number here. But the only difference is that the number itself. Option 1 is 2, statement 2 is 4, and statement 3 is 6. So basically it becomes a problem of plugging in 2, 4, and 6 in this number of fish in both groups, and then you find out what the corresponding P is. If P is less than 1,500, then we're gonna restock. Or if it's greater than or equal to 1,500, and we're not gonna restock. Okay, so you plug in the numbers, and what do you find?
For the first one, I had 1,800. So
okay,
restock.
So we don't restock for the first option, for this first statement. What about second one?
900. Restock.
900. Okay. So let's stop here. We know that with 4 fish in both groups, we're gonna have to restock. Then do we need to calculate for 6 fish in both groups?
No, because as the number of fish in both groups increases,
that's right,
the population decreases.
That's right, because the number in second group and the first group are constant. So if the number in the both groups increases, then P has to decrease so that the ratio are equal. These 2 ratios are equal. So we don't actually need to calculate for this third statement. We can go straight for it. Yeah. Okay. Let's see if it's correct. It is correct. Number 3. Assume that at the beginning of next year's fishing season, the fish population will be at the minimum level for the start of the fishing season. For each of the following numbers of fish removed from KGR during that fishing season, select yes if the model population increases. Pick that the fish population will increase by at least 40 fish due to reproduction. Otherwise, select no.
So here we would look at the tab.
What tab?
Tab 3, fish reproduction. We will look at the chart in the tab.
But what would be the minimum level for fish of the start of the fishing season? What would be the minimum level?
1,500. In the first
1,500. First tab. We can go back to the first tab quickly to check. Okay, and go back to this sentence that we already read earlier. No less than 1,500 fish at the start of fishing season. Okay, so 1,500. Minimum is 1,500. Okay. If 100 fish is removed, so how many fish would there be?
1,400.
1,400 here. And how many more fish would be the increase?
About 42%, 41%.
Well, remember that for the Y column is number of fish, not percentage.
Yeah, 40 fish.
Okay. And the question is asking select yes for cases where the fish population will increase by at least 40 fish due to reproduction. So do we select yes or no for this?
Yes.
We're gonna select yes. What about 200 fish?
We have 1,300 now, and it will be more than 40 in the y-axis.
It sounds like it's this spot is between 40 and 50. So about 45. So do we select yes or no?
Yes.
Yes. And 600 fish?
900 left.
900 left. So here.
Yeah. It will be close to 50.
Close to 50. So also yes. Okay. Let's check if we got it right. Yes, we got it correct. Woohoo. Okay, so very interesting question. Not too tricky, somewhat straightforward, a lot of information, but a good exercise to apply all that we learn about tables and graph and multi-source reasoning. Alrighty, so we're gonna move on to the last category of integrated reasoning, and then that will be kind of the last part. We can do 2 questions for this category, and then that would be for this session. Okay, this one seems realistic. All right, so for this last category, which is 2-part analysis, so it's kind of similar to the questions that we just did earlier, but the tricky thing is that we have to find 2 variables, and because we have to find 2 variables at the same time, our selection or our choice for one would impact the other. So for these kind of these 2-part analysis questions, what we really are looking for in the question prompt is the relationship between these 2 variables. So basically it's asking us x and y. So what we want to figure out is the relationship between x and y in the prompt. And then after that, we're gonna select, let's say this for x and this for y to meet that relationship, or this for x and this for y to meet that relationship. Okay. Other than that, we just read through the question prompt like you would do for a word problem question. Take notes and solve it. Yeah, but the key thing is to figure out the relationship. So let's take 2 minutes to read through the question and actually answer the choices.
To record on.
Freak. Alrighty. So let's kind of briefly go through the questions. What was it saying, and how did you find the relationship of these 2 variables?
Here they show that an insect has 5 traits, and the relationship between the traits. So they first start with trait A. A has either B or C, or both B and C.
B or C or both?
B and C. At
Mhm.
least one, right?
Yeah.
And then all C has either D or E.
Uh-huh.
So another layer of the tree.
Mm-hmm.
And all B has C.
Okay. All of the species with trait B also has trait C. So you can think of as C as this group, this big group, and then B would be a subset of that. Any species with trait B has trait C. So species with trait B is going to be a subset of species with trait C. And then because trait C has at least one of traits D and E, you can think of it as also a subset of D or of E or something like that. Yeah, not the prettiest, but you get the idea. Okay. And in addition to the relationship between trait B and C, that is static exclusively with respect to the first study. The passage implies that any of the insects that has trait X also has trait Y. What is X and what is Y? So we can figure out that X is going to be a subset of Y, right?
Mm.
Okay, and then what are you next?
And then we consider A.
Okay, so you're considering A for X.
Yeah.
Okay. So if any of the insects that has trait A, what other trait should it also have?
C.
C. Why C?
Because A either has B or C or both B and C.
Uh-huh.
We all know that all B's also has C.
Right. So basically, because here, if it has trait A, then it's gonna have either B or C. But if it has B, then it's gonna definitely have C because B is a subset of C. Right. So if an insect has trait A, then it's definitely gonna have trait C.
Mm.
But what about D and E? Well, we don't know for sure because any insects of trait C might have D or E, one of
Yeah,
the two,
or both.
right?
But
So
they
you cannot, yeah,
but they don't say anything about the relationship between B and D and E.
yeah. We don't say anything about the relationship between D and E, so we cannot conclusively say that an insect with trait C is always going to have trait E or always going to have trait E. Okay, so C sounds like more the safer choice for Y. Okay, so let's see if we got that correct. Yes, it is correct. Okay, great. So this one thing to take into account when we approach these integrated reasoning questions, especially not just two-part the analysis questions, but also graphs and tables, which is utilizing subsets or sets. Venn diagram is a tool. Tree, like a tree map like this, is also a tool. Do whatever you want as long as it correctly and sufficiently shows that one set is a subset of another set. And pay attention to the wording, just like what we did for this question. Okay, great. Let's do one more. Official guy. Clothing retailer. Ooh, that doesn't sound like a real question. Oh, this is a hard one. Let's try this one.
Okay.
3 minutes reading and going through the questions. Alrighty then. So can you briefly explain what the problem is giving us and how you approach solving for these two probabilities?
So the prompt gives us the probability of Rishika
Mhm.
being assigned to recruitment work, which is 1/2 or 0.5 or 50%.
Mhm.
And the probability that she will be assigned to new tech, which
Mhm.
equals 3/4 or 0.75 or 75%.
Right.
And they ask us the maximum probability that she gets assigned to both and the minimum probability that she gets assigned to both.
Okay. So we're gonna find probability, the greatest probability possible that she get assigned to both assignments, and the least possible probability for getting into both assignments. So how did you go about finding the greatest and the least probability?
So I draw 3 lines.
Draw
One
3 lines.
line equals 1 or 100%. The second line equals a half, 50% of the probability of her being
Okay.
assigned to recruit. And the line for 50% is half. It's much shorter. It's half of the size of 100%.
Oh, like by length. We're
Yes,
drawing the lines by length. Okay. So like this.
yeah, 50%. And another for 75%, starting at the from the left side.
Like this.
Yes.
3,
So
4.
yeah, new tech.
Okay.
In this case, we can see that if she gets assigned to both, then the maximum probability will equals 50%.
Why 50%?
Because it can only equals the recruit's percentage. If it equals 75%, then there's a 25% chance that she's not assigned to recruit.
Mm-hmm. So we can think of this as this is her probability for getting into our work, and then this is her probability for getting into new tech. We don't know any relationship between these two. So you say that if they are completely separate, right? They are not related to each other, then there's no chance that she's gonna get assigned to both. Actually, we can answer the other question too, but let's get back to that later. But if say they start overlapping like this, then now there is some chance for her to get assigned to both. And then what is the greatest overlap that could be for these two groups, which is when one group is completely in the other group. And which group has a lower chance of getting in? That would be recruitment work, right? So the high chance happens when recruitment work is a subset of new tech. Which is 50% probability. So that would be the greatest chance for getting into both, which is when recruitment work is a subset of new tech. If you get in recruitment work, then you automatically get in
New tech.
new tech. Yeah. So it's 50%. And then what's the least probability?
So I draw the Venn diagram.
Uh-huh.
where there's an overlap,
Uh-huh.
and then I name the ports A, B, and C.
Like this.
Yes.
Okay.
So A plus B plus C equals 100%. For the maximum, if there is no chance that she will not get assigned to any.
Which she assigns to several of the groups.
But for
Sorry.
yeah, and then A plus C equals recruit, which equals 50%.
A plus B equals what? 50%.
A plus C equals 50%.
A plus C equals 50%. So this is her chance of getting into recruitment work. And then this thing, this entire thing,
New
the
tech.
second circle is a chance to new tech. So A plus C is 50% and B plus C equals 75%.
Yes, but A plus B plus C equals 100. So the extra C will equal 50 plus 75 minus 100, which equals 25%.
So this is assuming she's gonna get assigned in some project, right? One of these two or both, and that's 100%. They have to be 100%. So if we add these two, it would be A plus B plus C and then plus another C, and that would be
125%.
125%, right? So this is an addition. It has an additional C in here compared to this, so we can calculate C as equal to 25%. So that's 1/4.
Yeah.
Okay. Let's see. Yay! Correct. Very good.
Can we solve it? Can we solve it by moving the lines that we draw at first? We drew it first.
You mean back to drawing the lines?
Yes. So for example, we have 100% again.
Okay.
And from the left, we have, no, make it the other way. It starts from the right axis. 50%. Keep the 75. Keep the 75. Yes,
like
but
this?
yeah, okay. And then we can see that the overlap here is the part in the middle.
So this is definitely 50%.
Yeah.
This is 50%.
Mm-hmm.
So this is 25%.
Yeah.
That's what you mean?
Yeah. Can we solve it this way as well?
Yeah, I guess it's just like it is follows the same logic, just different different kind of expression, different visualization, but still the same logic.
Okay.
So we can solve that way. Okay, great. So that's it for today. We got quite a bit of practice with the integrated reasoning questions with 3 different types. So the questions that we practiced today would be put into a list so you can review later and do it again later. Yeah, so that's it. Thank you. One person joining this session. See you some next session, probably next weekend or weekend after that. All right, thank you. Bye bye. Ok, em còn thắc mắc gì không em?
Anh ơi dừng đi, anh vẫn đang record.
Yeah, anh đang tìm